We've discussed lengths of standard quadrilaterals, but there are some other properties relating to angles and diagonals that we should know. So if we look at the square, we know that all the sides are equal in length, and we know that all the angles are 90 degrees. But if we draw in the diagonals, these diagonals are equal in length. Not only that, but they bisect each other, so that all four of these lengths from the vertex to the center are the same. Note that this marking doesn't mean they're the same as these ones. This is a separate diagram. They also meet at 90 degrees in the middle. Now with a rectangle, we know that opposite sides are equal in length and that all four angles are 90 degrees. The diagonals also bisect each other, so the length from here to the center is the same for all of these, and that means also that the whole diagonal here is equal in length to the whole diagonal across here. Note they don't meet at 90 degrees. If we look at the parallelogram, we know that opposite sides are equal in length. It's also true in a parallelogram that opposite angles are equal. We can see that with the single marking on these two angles and the double marking on these two angles. Where the diagonals meet bisects them, which means that if we look at this diagonal here, it's cut in half so that this length here is equal to this length here, and the same happens to the other diagonal. But of course the diagonals themselves are not equal in length, and note the angle where they meet is not 90 degrees. Now here we have a rhombus, and a rhombus is a special case of a parallelogram where all four sides are equal. So note once again the opposite angles are equal, so these two angles are equal here and these two ones are equal here. The diagonals once again bisect each other, so if we consider this diagonal down here, where they meet in the center, this length from the vertex to the center is the same as this length from the vertex to the center, and the same is true on the other diagonal, but of course the diagonals themselves are not equal in length, but in a rhombus they do meet at right angles. We know that a trapezium has two parallel sides. This one here is a special one called the isosceles trapezium, and that has these two lengths equal, and that means that these two top angles are equal to each other, and these two angles, known as the base angles, are also equal to each other. The diagonals are equal in length. They don't bisect, but they do cross, so that these two are equal in length and these two are equal in length. But if we have a trapezium that isn't isosceles, there are no obvious properties. If we look at the kite, we know that adjacent sides are equal in length, or we have two pairs of adjacent sides equal in length, because these adjacent sides are not equal in length. The long diagonal here is a line of symmetry of the shape. So what we have are congruent triangles here and here, and these two angles are equal. The long diagonal is not bisected by the short one, but the short one is bisected by the long one. So the distance from this vertex to the center, just shown here, is the same as the distance from this vertex to the center, and the diagonals also cross at right angles. Calculate the unknown angles in the diagram below, given that HIJK is a trapezium. Well, if HIJK is a trapezium, I know that these sides are parallel. Then I can spot a Z. That means I have alternate angles, and this angle here must be equal to this angle here. So we can say that Y is 127 degrees. Not only that, but angles on a straight line add to 180. So 180 take away 127 gives me 53 degrees. Now we know the four angles of the quadrilateral are going to add to 360, so that's x, add the 66, add the 53, add the 127 is 360. So if we do 66, add 53, add 127, that gives us 246. And then we'll just take away 246 from each side, and we get 360 take away 246, giving us 114 degrees. Now we're told that LM, which is this length here, is 8 centimeters. We want the length of LN, which is all the way from here to here. But we can see that we have a parallelogram, and therefore we know that this is also 8 centimeters because the diagonals bisect, and therefore LN is 8 plus 8, which is 16 centimeters.